So the next thing we're going to look at are string methods. And your book has a complete list of string methods, and then you can also look them up in Python documentation. The first one we're going to look at is the find method. So let's make a new program and call it find method demo.py. And we're going to make a sentence is equal to with a moo here and a moo there. And we're going to say sentence dot find moo, and we'll make a variable to store this in of moo is equal to, and then we'll just print that. We'll say print, and we'll say location of moo. And let's run that. And it gives us 7. So if we look at this, 0 is the W, 1 is the I, 2 is the T, 3 is the H, space is 4, 5, 6, 7. We can see that this M is located at index 7. And we could, if we printed sentence index location of moo, and then we'll say to the end, maybe, yeah, we'll do that. We'll see that we'll get everything from moo here all the way to the end. So that'll show you that we found the start of where this is, of this first moo. So that's what the sentence.find method does, is if you give it a string, it'll find the location. Well, let's see. Could we do this with index? Let's see what that does. Because we had this index method that was a common sequence operation. And we'll do the same thing here. And I'll just put a print here with dot find, and then I'll put a print here that says, and I'm going to put a \n so that we have a carriage return with dot index. So that way we can see the difference. And oh, I need to make one more change. Let me stop that. It's because we want to show the index. And let's see if that works. And notice both of these work. So what's the difference? Well, what if we were looking for something that wasn't there? There isn't a blah in here. And let's run that. So now we're looking for something that isn't inside of this list. We're finding it first, and then we're trying to do the index. And let's move this up just a touch. So with find, notice that what we got back was actually a -1. So with find, it gave us a -1, and it didn't actually cause an error. But when we try to do it with index, we get an error. So it says index of move, when we did sentence.index blah, substring we get a substring not found value error. So what this tells you is that, so the advantage of find over index is basically find will return a -1 and it won't stop your program, but this index causes error if substring not found. And then here dot find returns -1 if substring not found. So whether to use find or index depends on how you want, whether you want to have it throw an error or whether you want it to just return -1. And we'll learn later how to handle errors. So sometimes this is the right answer, or sometimes that's the right answer, but you have both options in Python. So another thing is, let's say that we want to find the second move here. Well, how could we do that? I'm going to leave this at the bottom since it drives an error. And let's see. Put it here, and we'll say find second move. Well, how would we do that? Well, there's actually, we can actually put a starting point. And so if I started searching from, let's see, we found it at 7. If I started at searching at, say, 8 from here on, or if I started searching from this point on, I would find the second one. So I'm going to search from 8 and see what happens. Oh, I'm sorry, this needs to be a comma. So what this is, and you can see it up here, find the first parameter. So the first parameter is the string you want to look for. The second parameter here is the start point. And so in this search, it's going to start looking for, and I'll change this to of second move. And so since this one's going to search after, from here, in this part here, from here on, it's going to search that area there because it's starting at 8. It won't find the first move with this find. This one will find the first one, and this one will, and we need to change this back to move. And for the purposes of making this demo complete, so we're going to find the first move, find the second move, look for something that's not there, and then look for something that's not there with the index function. So here, we're going to start searching after the first one, and this should find the second one here because, if we start from here, the OO is not move, so it won't find that first one. So let's give this a try and see what happens. And what we find is, let's see, we'll have to scroll up a little bit. So the first one we found at 7. And the second one we found at 11. So that makes sense because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's at index 11. And we did, in fact, find the second one. And you can see it starting here. So you could actually go through and find the next one just by, if we kept iterating this. And to make it easier, if we think about it, what is 8? Well, it's really the location of the first move plus 1. And then we could repeat this. And we could say that the location of the third move is the location of the second move plus 1, and we'll display that information. And you can see how this iterates through, and we will find the third location. As long as we're always searching for starting one space beyond where the last one was found, we should find all 3 of them. Let's change this here, also say first move. And the first move is found at 7, the second one's 11, and the third one over here is found at 27. And you could do it one more time and find the fourth one. So, of course, this is pretty repetitive. Could we clean this up? Yes, with a loop. And later on, we're going to learn how to use loops and do this in a more iterative fashion so that we only have to write this one time and put it inside of a loop. But that demonstrates how you can search through by using this, by adding an index number as your second parameter in this function or second argument. So this function is now, this is the 2 argument format of the find method. And, the second term is basically an integer. So this resolves to an integer, it ends up being 8. That says, hey, don't start at the beginning, but start from this location. So there are actually several different methods that do the same sort of things. There's right find, which rather than looking from the left to the right, it looks from the right to the left. We saw how the index works. There's also a right index that will search from the right side when doing indexing. And there's a count method that will return the number of instances. Let's try that with this. We'll try the count. So if I go up here, and we could say find a number of moves in sentence, and say count of moves. So I just pick my variable, and I can say sentence.count. And notice that once you've established something's a string, there's also the full list of all of the string functions here. In fact, there's a whole lot more than what we've put in here. And so we're going to say count moo inside of this, and then we're going to say print there are count of moves in a sentence. And so let's try that. And let's see what we have. So at the top of this execution, there are 4 moves in this sentence. So yes, it was able to count up the number of this substring inside of this overall string by using this count method. And then, and then there's also, does it start with moo? We could say starts with moo is our variable is equal to sentence dot starts with, and we'll put moo, and then we'll say and then we'll display it. And then maybe what we'll do is and then we'll also test to see if it starts with. And so what we're doing is here we're doing checking to see if it starts with. We anticipate this one will be true and this one should be false. So let's try that. And there we see it. Yes, it was able to figure out that sentence doesn't start with moo, but it does start with the word with. So those can be useful later on when we learn conditionals. We can actually make decisions based on what sentence we have. And there's also an ends with that works very much the same way. But basically, to use these methods, you look for starts with and ends with. Another method that's useful is the join method. So I'm going to make another program for this called joindemo.py. And let's say that we have a list. It has these 5 numbers. And then we're going to make another list called separator. So one sequence and one separator. And we're going to put a plus. And we're going to say result is equal to separator.join and sequence. Let's see what we get with this. And then we'll print this result just to test this out. And we get an error. Sequence item 0, expected string instance int found. So the join method doesn't work with integers, but if we change these all to strings, so rather than integers, if I make this a sequence of strings, so each one of these, now I'm putting quotes around them, this is now a sequence of strings, and I run this, watch what happens. And what we get is we can see that a plus was put between each one of these strings, and everything was concatenated together into one string. So this can be useful. Let's say that what we wanted to do was actually something like this. I'm going to comment this out just to hold on to that as an example. But let's say that we had a list of directories, and we're going to say we're going to do this. So what am I doing here? I'm putting in several strings separated by a comma. And what is that? So just to see what this ends up as. Oh, look. Remember that Python considers anything separated by commas with no other designators around it, no square braces or anything else. By default, assumes that what you intended was a tuple. So by saying DRRs is equal to this, I made a tuple out of these elements. And then what I'm going to do is I'm going to say print backslash dot join DRRS. And what is that going to do? Well, what it did is it put a forward slash between each one of these. And this is, if you're familiar with Linux, that's a path in Linux. And they use forward slashes, and we put all of them between it. Now, why isn't there one at the beginning? Well, because I started off with an empty string. If I didn't have this empty string, watch what would have happened. It wouldn't have put the leading forward slash, and in Unix you kind of need that. So if you have a list and you do want the separator to be in front of it, you can just put an empty string in front of your sequence, and it will put an element in front of it. You could also do it with the end as well. But this could be handy for a number of use cases. And yeah, so you can see that now with the empty string at the beginning of our sequence, it just puts an empty in front of a slash so that we can get a forward slash in front of it. What other uses could we use for this? Let's say that elements or names is equal to and I'll use a list this time, Rob, Alice, let's see, Bill, and let's say I wanted to display those separated by comma. Well, what I could do is I could say put a comma dot join names, and let's see what happens with that. And you can see now we have it separated by comma, but there isn't a space. So what I might do is put a space here and run that. And there we have everything separated by comma. And notice we don't have a comma in the front or the end. If we, if we just kind of printed them all and then add them, the nice thing is that this keeps from having a trailing comma on your list. Now, the other thing you can do is you can also just say names. You can make a variable separated by comma is equal to, and you don't have to. You could also just take that and put it in a variable, and then display the variable instead, and that will work too. So this basically constructs a string, and you can either print it or put it in a variable, and it will work. Now let's say that we wanted to put them on separate lines. Well, we could do that too. I'm going to say names separated by a line is equal to, and what we would join is \n, which is a carriage return, and then we could join names that way, and then we'll print names separated by a line, and now we're putting, in fact, we don't need this space really. In fact, that space kind of messed it up a little bit, so I'm going to get rid of that space there, because you see how it sits there. And I think I'm going to put a little print statement here that says names on separate lines. And I'm going to put one here that, just so that we can see what we're getting. Names separated by commas. And it'd be nice to have a caricature. So here, so I'm going to put a backslash n in front of each one of these so that we get a line in front. Let's see what that looks like. So we're joining by a comma, we're joined by backslash n without an extra space so it doesn't kick it out one more. And this should look better. And there we go. Name separate by commas, name separate on separate lines. We can even separate by tabs if we wanted to. And I'll change this to a tab. And we're going to put a backslash T. That's actually a tab character. And we'll run that one. And we can see now they're separated by the tab character, which is usually about 5. Well, it puts them at particular intervals. So tab character is kind of interesting. But all of these can be useful as ways of, taking a list and displaying it in a nice manner. So another method that can be useful is changing the case. So I'm going to call this one casedemo.py. And we're going to get someone's name. So we'll do input, please enter your name. And then we're just going to say print name as entered, comma, name. And let's just try that first. So and so I'll put in my name, and we can see that, just as I wrote it. Now let's try this. And name in lowercase. And what we can do is you say name.lower. And notice the lower method doesn't take any parameters, but we still have to put open close parentheses. So any method that you want to call, even if it doesn't have any arguments you're passing in, you still need to provide the parentheses because Python uses that to know that you want to call this method. Let's see what name.lower does. And so, and I'm going to type it this way. I'm going to capitalize the O and leave. And you notice that what it does is it takes everything with lower and makes it lowercase. We can also do this, of course. We can put it in a variable. We can put it in a variable first and just use the variable in our print, and it will do the same thing. So sometimes you might want to do other manipulations with things first, and so you can put them temporarily in variables before you use them. And I'm just, and you can see there it's lowercase. We can also do this. We can say upper name is equal to name dot upper. And let's see, upper name. And we'll try that. And so here I'll put in, I'm just going to put in the same thing. And we can see it took and did a lowercase. This one converted all to uppercase. And then we can do this one. Name.title. And let's see what this one does. Need to close that. And I'll copy this again and put it in here. And notice that it took a messed up casing here. And the nice thing about title case is it takes the first word, the first character of each word and uppercases it and then makes everything lowercase. So you can use upper, lower, and title to clean up input that you get. Another method that we'll look at is the replace method. So I'm going to make a demo called replace demo.py. And in this one, we're going to say text is equal to this is a test. And then I'm going to say new text is equal to text dot. Actually, let's do this. I think we can do. Let's try text dot replace. We're going to replace is with isn't. Since I need to use a single quote in here, I'll use double quotes on the outside. And let's print text and see what we get. And notice that, well, this didn't do anything. If I just do text.replace, it just says this is a test. Well, it turns out that what we have to do is the text.replace function will make the replacement, and it returns a value that has a replacement. Remember, strings are immutable, so we can't really modify the original text. So we have to say new text. We'll say new text is equal to that, and we'll display this new text. So we have to put this, the result of this, into a new variable and display that variable. And we'll see if that works. And unfortunately I grabbed this first is. So maybe what we'll do is, let's see, do we have yeah, we yeah, it says this isn't a test because it's replaced both of these. So how could we fix that? Well, we could just do something like this. We'll say it's the first part. So we'll go from the beginning to 0, 1, 2, 3 to 3 plus text 3 to the end and see if that works. And then what we did is by doing this, we skipped over the first 4 characters, and then we did the replacement in the last 4 characters. So the big thing with the replace is we pass in a string and we put in what was there before and what we wanted afterwards, and it will do a replacement. The next one we'll look at is the split function. So I'm going to make a or split method. So I'm going to do split demo.py, And let's say that we have some text, and it is something like this: 12.3 comma August earnings, and then 1 2 3 4 5. And what we want to do is we want to get this into a list. Right now it's a big string, so let's say we wanted the first element. If I said print text square braces 0, let's say I wanted that 12.3. What am I going to get if I say 0? Well, I'm going to get the 1, right? The first character of this thing. What I want, let's say I want this whole thing, though. How could I do that? This is where the split function comes in handy. So, let's say we're doing something like this. Get a line of text. And then what we want to do is split text on the comma, and then display first element. Well, we could say elements, and just a variable name, is equal to text.split, and we can say we want to split on the comma. And then and let's display elements. And then we'll display the first one. And so now we're using elements. So we'll look at we'll display index 0 of that and see what we get. And there we see we are able, when we split it, it made a list with all of these elements separated out by individual strings, and then it just gave us the first one here. Now note that this is a string, it's not a number. If we wanted to treat this as a number, we would do something like this. We would say maybe float. We'd wrap it in a float command so that it would be an actual number. We won't see much difference with this, but if you want to do math with it, you would convert it to a float. The other thing that we could do is, let's say that we want to display this in here on separate lines. We could say something like this. Since everything's a string, we could say \n dot join, and we could join those elements. Oh, I misspelled. And let's put a prompt in front, print. I'm going to put a \n so that we have a carriage return, and then elements in text. And then maybe here what we'll do is display text. And then here we will print and let's give that a try. So we're going to display everything with a prompt in front of each one so we know what we're looking at when it displays. And there we go. We see the original text. We see it split. There's just little spaces in front because when we split on a comma, it has that space right here, which could be a problem. And then we have our first element here displayed. And we could play, and we could even do this. We could replicate this a few times. And so, of course, we would display 1, and then third element, element 2, and let's try that. So now we'll see that we can, and this is just to demonstrate that, you know, we can pick out, once we split, we can pick out the elements that we want. Oh, we have a problem with second element. Oh, we can't float the second element because it's a string. And let's see, the third one is a number, so I think we can, yeah, that one's an integer, so maybe this one we'll put integer in front of. And let's give that a try, since the second element is a piece of text. And you can see this cleaned up these numbers nicely. It got rid of the leading space on the number on 1, 2, 3, 4, 5. We had this leading space here because we turned it into a number. But how can we clean that up? Actually, we can do a dot trim, or let's see, do we have a function for that? Strip, actually, it is. And what this will do is it'll actually get rid of any leading and trailing spaces. And so returns a copy of the string with leading and trailing spaces removed. So we can use that method to actually clean up this one, so we don't have spaces in front of and behind it. And now you can see that it's now left justified, and we have a nice clean string. So all of these, there's lots of different methods, and you know, whenever you're dealing with a string, you can just put a dot here and let IntelliSense show you and look up these functions, and you'll find a lot of times these have tools or that could be very useful. So that's the split demo. Thank you very much.